Hey, this is Leach with Simpson Math, and in this video I'm going to be talking a little bit more specifically than I do in most of my videos. I'm going to be talking about section 2.1 in the Larson statistics textbook. I'm running an online summer math class right now, and in that section, in my opinion, it's a little bit annoying. It does some things that I don't really like, but you work with what you're given. So I'm going to cover just real fast an idealized idea of what I would like you to get from the big pictures of that section, and then I'll dive in and show you a few specific examples of how to answer the questions in the ways that they're wanting you to do. So first, I'm going to give you kind of a big picture overview of things from that chapter, and that's dealing with frequency tables and ultimately kind of making histograms from our data. A big fault that our book does is that it assumes, and this whole section is kind of dealing with assuming that all data are discrete or positive integers, that I'm like just counting up number of things instead of dealing with stuff that could make sense that there would be decimals. Most measurements would have decimal values. If I was measuring people's heights or things like that, there should be decimals. So I'm going to give you a set of examples from my real life as a little hobby. Jimson, my husband, John Simpson, he's also a professor at TC. We make these enamel pins. So this one is an apple pie. Here's this one. This is a Legend of Zelda themed pin. Deals with the Pascal's triangle that looks like the Triforce, if you know about Legend of Zelda. We'll talk about the Pascal's triangle in a few chapters. So I'm going to flip over my screen and show you a histogram of a set of data. This data comes from our sales on Etsy, since we opened an Etsy shop a few months ago. And so these are each individual order. So most orders, these pins sell for like $11. So we get a lot of people who order just a single pin. So they're in that 10 to 20 range, as you can see here. So they have a big bar that goes up to like about 55. That their order total. So this is counting the cost of the pin, taxes, shipping, all the things. So there are orders from those that would be exactly 10 all the way up to almost 20. So in this case, $19.99. If a cell was precisely 20, it would then be in this next bar. So that's how we can read this graph. And we can see that a lot of people have a cell between 10 and 20. So I'm here on a program called Desmos. If you were to start this from scratch, you can come to a blank line and you can type in, you would need to create a list name. So let's say, give it a single letter like A equals, and then open a square bracket, and you can start typing in your numbers. And you can see I just did 1, 2, 3, 4, and it knows that it's a 4-element list. Let me put in the number 8, just so you can see it's not counting the last number, it's just saying that there's 5 things there. So I could change this to be a histogram of set A, which is not a very insightful list. Let's say I want it to be a bar with a 2. And so here's a histogram of set A with bars width of 2. So here it's starting from 0, going to 2, 2 to 4, 4 to 5, 4 to 6, so forth. Nothing there was between 6 and 8. So the first box, the first entry is where's your data. Second entry is where's your is how big your bars are. Let me put it back to my data set, which is S for sales, and I had it at 10. So notice within this I have a few options. It's not so much of a tech demo right now. I'll show you a few different options about tech here, but just kind of the big picture here is that notice that this data makes sense to have non-integer values. It sells. I'm not needing to round. So there is no space, 0 space between these bars. When one bar ends at $10.99, we round to the nearest penny when we deal with money. The next bar picks up at 20. I can make these bars be a little bit smaller, so I can adjust this to maybe say 5. And you can see it instantly changes, and now the bars are 5 units wide. So 10 to almost 15, 15 to almost 20. Notice we don't have anybody who their total came to be somewhere between 20 and almost 25. This because of tax and shipping and how that kind of turned out. So there's that. Notice 5 might be good, might be a little bit too small. 1 would be way too small, so it's kind of looking like skyscrapers. And if I did a bars of like, let's say 50 units wide, you can see obviously that is way too big. So there's a definite sweet spot when it comes to histograms. Typically I would say that with histograms, it depends on the amount of data that you have. 10 here might be on a little bit on the big side. 5 is a little bit on the small side. So kind of anywhere 5 to 10 are kind of the lower to upper bound that I would do it. I don't like to do bars that have like 7 or something, because if I'm looking at this, it's like, what is this number if I couldn't count it directly? Our brains were used to thinking about things in base 10, base so numbers that are even, numbers that are multiples of 5, multiples of 10 kind of tend to make sense to us. So, or if I have a data set that I have lots of values, maybe 3 could maybe work well. That's a good familiar number. But basically, bars that bins that are bin widths that make sense, that are the right, that are a plausible size. And you don't want too many bars. You don't want too few bars. Kind of have that Goldilocks, just right size. Sorry. So that's how you would do this on Desmos. If you're working in my lab, a lot of the times with the histograms, you're really just doing a multiple choice approach, which we'll cover some questions about that. So I wouldn't worry about trying to make the histogram. If you did, you could copy the data out and then paste the data into Desmos. And when you paste the data in, like this data I pasted in from Excel as a column list, and it auto-formatted it with those commas separating it in the square brackets. You can, but I wouldn't worry about it too much. Let me show you how to make a histogram like this in the TI-84. So I'm going to pop up a TI-84. I've already put the data in, but let me show you where that lives. So go to Stat, Edit, and you can just type in your data. This TI-84 is connected to my computer, so I was able to copy and paste the data from my spreadsheet, so that was nice. So I have my data all, I think it's like 71 values or something in there. So I'm just going to press second mode, which is quit, which just gets me back to the home screen. So now I'm going to plot this histogram. To do this, you notice where on my y equals it says stat plot. So I'm going to say second y equals, and I got my stat plot options. So I'm going to just pick plot 1. First thing I need to do is I need to turn it on. So click enter to switch it from off to on. And now we need to pick the type that we want. This is a scatter plot. This is a line connected scatter plot. This is a histogram. These others, this is a box plot with the with outliers, box plot without outliers. I believe this last one is a normal probability plot. So pick the histogram, because that's what we're graphing. It asks where the data lives. It lives in L1, that's where we put it. If for some reason you had your data set in L2 or L3, then you can press second 2 or second 3, all the way up to L6 to be able to get the, to be able to tell where the list is. We didn't have a frequency list, so just leave it at 1. That 1 is doing a multiplier, so we don't have to mess with that. It's just multiplying all the data values by 1, which doesn't change anything. And you know, you can change the color if you want to. All right, so now I'm going to press, let's go zoom, and then go down and pick number 9. You can also just click the 9 button, but zoom 9 is zoom stat, so it will zoom in on the data. Oh, just like, let me show you real fast. Go back to here. If I've changed on my Desmos, there's another zoom fit here. This magnifying glass right there. So if you click that, that zooms into your data. At least a pretty good starting point. So we pop this back up, and we can see that this histogram matches what we saw here. If you arrow around, I believe if you press the trace button, press trace, you can then arrow around, and it will tell you this bar is from 14.75 to 20.492857. Those aren't very practical, and it is 54 tall. What if I want to have it match exactly what's on the Desmos screen behind me? So then go to Window, or in this case, especially if you really wanted to force it to be something specific. With Desmos, I forgot to mention, on Desmos you can just do a center adjustment or left. The center is, here it's centering at multiples of 10, 0, 10, 20, 30, 40. Instead of going from 0 to 10, 10, 20, 30 to 40, it is centering it on here. So this bar actually goes from 5 to almost 15, 15 to almost 20. If you have the data set is just integers, and you would want your bars to be a bar with a 1, that's the big time that I would do that. My bars or my bins would be with 1, centered over your numbers, and that would kind of make sense visually. But let me go back to my 84. So press Window, And then on window, I'm going to change my X scale to be 10. So I change my X scale to be 10, and what's my biggest number? At least up into the 60. Then that will auto take care of it. The X scale is the bin width. So if I just press graph now, I took it from the calculations of just the 84 trying to do what it thinks is best to me kind of forcing it. So now when I press trace, I see that first bar. I do need to change my bar to be starting at 10. So let me go back to window, and I'll start it at 10. And then the Y scale, the X max doesn't really matter then. So now if I go to graph, yeah, so there's the, this is, press trace. That's 10 to almost 20. Do you see how they have that with saying less than 20? 20 to almost 30, 30 to almost 40, 40 to almost 50, 50 to almost 60. So there's that histogram. If I wanted to see what it looked like when we switch it down to a scale of 5, a bin width of 5, I could swap it to 5 here. And that's what we saw a second ago. So that's how you would do the histogram on Excel. I mean on the 84. Now let me show you real fast. I'm going to show you how to do the histogram on Excel because it's a little bit annoying and not accurate, I think. But within chapter section 2.1, you're going to be having to calculate the bin widths by hand and find how many things are within them. So let's say this data set, this same one we've been looking at, I have 71 total numbers. What I'm going to do is I'm going to sort this data from smallest to largest. If you're familiar with Excel, then this might be a handy thing for the few questions that you have to deal with. Otherwise, I'll show you a nice workaround. So I'm going to highlight column A, come over here to sort, and tell it to sort from smallest to largest. So now all my data is set from smallest to largest. So the smallest purchase order that we ever had was $14.57, and the biggest was $56.03. So if I've decided that I want to start at 10 and go to almost 20, then I could just count, see how far down I need to go until I get to that almost 20, and I would see there's that pretty big jump right here at 13.38. So that's where we get the 55 total things in that first column. Or if I wanted to look at it a little bit smaller, and so from 10 to almost 15, I could see here's 10 to almost 15, and the rest of those all the way down to, like I said, all the way down to here. So you can just go through and just count once you sort it. So I just wanted to show you that sort tip. We'll look at more examples actually right now. So that's how I would do that. So if you can pull the data in and sort. There is a way to do histograms. You can go into insert right here, histogram, and it will try to do it, and you can do your edits as you need to. It's not the best. I don't like how it does the x-axis, so I'm not going to make a big deal about it. Let's now look at some examples. So I'm going to be looking at what should be 5, 6, 7, 11, and 12 on your homework. It should be here? No, this one. Where was the second go? Am I still in, or is it angry? Okay, I'm still in. Okay, so I have these questions pulled up. They're already solved. I just want to show you how to kind of do this calculations with some of these things. Like I said, not a fan, so I'm just kind of giving you a bit of a nudge with this. So it says use the given minimum and maximum data entries and find, this is question 5, or in case the question numbers have changed, 2.1.11. Use the given minimum and maximum data entries and the number of classes to find the class width, the lower class limits, and the upper class limits. So just talk about that vocab real fast. So class width on my histogram here was 10. Each of these are 10 units wide. My lower class widths are nice normal numbers, 10, 20, 30, 40, 50. And the upper class limits I have are 20, 30, 40, 50, 60. Notice I have no gap between here. Look over here. This one it's saying that the lower class is 12, upper is 20 for the first bar. The next bar it jumps a whole unit over, and there's like, it's basically has an empty space between 20 and 21. What it would do, what it would want you to do, the book wants you to do, is make the histogram bar land at 20 and a half, 20.5, which I think is just confusing. So I'm not, that's again why I'm going through this. So they want 1 unit of separation between the upper limit of one bar and the lower limit of the next bar. So let's kind of go through this and show you how you would get these numbers. I'm going to go back to my calculator. I don't need the graph. So the first thing I'm going to do is I'm going to find how wide my class bars, how wide the bars should be. I'm told that there should be 7 classes between a data value, the smallest is 12, the biggest is 71. And the book wants you to put your smallest data, the bar starting on your smallest data value. But the bars could extend past your biggest one. So they want you to round the class width to an integer, but that it will probably bypass your maximum value, but it has to at least get there. So to do that, I'm going to take my maximum value, the minimum value, and subtract them to find the range. 71 minus 12, and I get a range of 59. So I need 7 bars to cleanly fit all the way to at least 59, but it might go past 59. So to do that, I'm going to do the 59 divided by 7. And when I do, I get 8.4-ish. If I made my bars to be only 8, and I started at 12, and I skip count up all the way up, I would not quite hit 71. I would actually need an 8th bar to be able to capture that 71. So we're going to round this 8 up to the next integer to 9. So that's why the class width here is 9. Then, so my lower bars, what you can basically do is add that class width to that minimum. So notice I have to do 12 plus 9 to get 21, plus another 930, plus 9, plus 9, plus 9, plus 9. So that's where my lower class limits are. For my upper class limits, basically if the next class is starting at 21, class, bar, bin, all those are kind of the same thing. My next class is starting at 21, the previous class should end 1 integer before that, so subtract 1 and get the 20. Or you can think, if my class width is 8, then the upper class limit would be this kind of, you can mathematically just add 8 to get to this 20, but notice that it does cover 9 things. It covers, I'm going to count with my fingers, so watch my camera. If I count 12, that's the first one, 12, 13, 14, 15, 16, 17, 18, 19, 20, notice that covers 9 things. So that is a class width of 9. If it counts all of 12 and covering all of 20, that is still 9 kind of numbers. That is 9 numbers in that way. So the bar is 9 wide. If I start at 12 and go all the way up to 20, that is covering 9 values. So mathematically, you can think 12 plus 9 minus 1 to get at this 20. But you really are covering those 9. So that's, I kind of have to touch my fingers for that to make sense. But once you get that, that's 1 less, and then you just add 9 all the way up. See, like I said, this is confusing. In my way, if I was doing it, I would, maybe if I had to use them to be 9 wide, I would just have the bar go from 12 to 21, and the first bar goes 12 to 21, second bar 21 to 30, and that's it. There would be my upper and lower bounds, but that's the way this goes. So hopefully that should help make sense about this question and the others. We're going to cover 6. So I'm not going to cover all of this. Just want to make sure I cover some of these vocab terms. Notice again how the classes are used here. The classes are 11 units wide. I know it seems like it would be 10, but 1 more, because if I start at 15 and count all the way up to 25, there would be 11. So we have 11 units wide here, and notice we have 1 unit between this one ending and that one starting. So they even did the frequency for us, because that's what this table says. So let's talk about these vocab terms real fast. Midpoint, that's just the number in the middle. So it's a term that's used throughout statistics, but not heavily, but it is just kind of there. The midpoint is just the location, the point on the number line between 2 numbers. So in this particular case, it's the midpoint of my bar. So if one bar starts at, if the bar starts at 15 and ends at 25, or the class rather starts at 15, ends at 25, the number smack dab in the middle is 20. How do you get that? Especially if they're not numbers intuitive like 15 and 25, you average them. So 15 plus 25, and then pop the calculator back up. So I can just say 15 plus the 25, and then divide that by 2. That's where you get the 20. If you have a calculator like this, you can press the 84, you can press alpha y equals to get a fraction, fancy fraction, and you can put that in the numerator and then divide it by 2 in all one big step. So that's how we get that midpoint. Now we need the relative frequency. So if you were to, I don't know, I was talking to my husband earlier, and I said something was going to be happening soon. I was like, well, soon's relative. Soon could be 1 minute, 1 second, 1 month, 1 year. Soon's relative. Well, our frequencies are also relative. So say that you are you walk into a room and you are asked, oh, hey, raise your hand if you're left-handed, and there's 20 people who raise their hand that are left-handed. Is that an astonishing number? Well, that's relative. If there are 20 people or 21 people in the room and 20 people raise their hand, you're like, what am I at a left-handed convention? But if there's 2,000 people in the room and only 20 people raise their hand, that's remarkably low for the expected percentage of left-handeds. So it's all relative. So relative to what? Relative to the total. So in this particular case, it says this is the some location, this is the high temperature, the daily high temperature. Notice if you add up all the frequencies, you do get 360. So I'm going to use that fact and take this 18 and divide it by 3. Oh, sorry, I said 360. I meant 365. Divide it by 365, and that's how we get this relative frequency of just about 5%. So in 5% of days, the high temperature was between 18 and 25 degrees Fahrenheit. See, again, it's weird because they're rounding temperature to the nearest degree, which we know isn't necessarily the case, but they're kind of forcing it to be like that. And then, so that's where all these relative frequencies come from. And then let's talk about lastly the midpoint. Oh, sorry, not the midpoint, the cumulative frequency. So cumulative, it is something that accumulates. So think about how people like Elon Musk, Bezos, and those people, they accumulate wealth. They gather and they add on, they build wealth, they accumulate wealth. So that's what the cumulative frequency does. It accumulates the numbers. It is accumulative. So the first bar, there's just 18. There's nothing less than. If I go all the way up to 25, there's only 18 days less than that. So if I accumulate the first bar, first class, and the second class, how many days are there? Well, it would be this 18 plus this 41, which gives me that 59. What about all the way up to 47? Well, it would be the 18 plus the 41 plus the 68 to get this 127. So if I keep adding those up each time, I'll get these numbers over here. But if I'm down here in this last row, next to last row, to get this 339, I don't want to add 18 plus 41 plus 68 plus. When previously I would have just found that this previous bar was 271. Can't I just say 271 plus the 68 to get the 339? And that's the ideal way to do the cumulative frequency. So you set your pattern on the first one. So you just set your first one. So 18, this is 18. Then this next one, I'm going to do 41 plus the previous one, which is 18. Then I'm going to do 68 plus the 59. Then 69 plus the 127, so forth, all the way down. So that's how you can quickly do the cumulative frequency. 7, just want to mention, this is called a frequency polygon. The thing that most students have a hard time with on this is that, let me pop this up and draw on here real fast. So with this, there is a midpoint. These dots here are actually at the midpoint. Whoop, went a little crazy. Are actually at the midpoint of a histogram. And can you see those lines? Yeah. Let me make it a little bit brighter, maybe. So these are the midpoint of those histograms. Midpoint of the histograms. The other thing is that it will start and stop the frequency polygon at 0. So if I was to turn this data from this frequency polygon back into a histogram, it would look something like this, where from that's halfway between 10 and 13, so 11 and a half. 11 and a half to 11.5 to 14.5 would be that smallest bar, and then on up. And then our biggest bar up here, which I think is the question's asking for, is this 29.5 all the way up here to this 32.5. So that's the endpoints here are on either side, because that dot that they gave us is in the middle of the bar. That's the midpoint of the bar. And the boundary of the class for the least frequency, that's this one that I highlighted, this 11.5 to 14.5. And again, they start at 0, just so that way this slope, this line can go somewhere. So it always goes to the next, what would be the next bar, and gets down to 0 on either end. So that's a frequency polygon. The benefit of that is that you're looking more at the changes from one class to the other instead of just the totals. You're kind of observing the changes for if that was the story that you're wanting to tell. So that was 5, 6, 7. I'm going to jump over to 11. All right. So with this one, it says construct a frequency distribution and a relative frequency histogram for the data set using 5 classes. Which class has the greatest relative frequency and which has the least relative frequency? Ooh, let me show you that word relative frequency real fast on Desmos. So notice here this says bar heights. If you switch it to the word relative, it looks like it disappears, but let me zoom in on it. And looks like what we had just before, but instead of this bar going up to 55, notice it's going up to, that would be like 77.5 or so percent. So these are now relative frequencies out of proportions instead of out of percent. So this Y scale is out of 1, not out of 100. But I can turn this, about 0.7-ish, 0.77 or so into 77%. So that's that with that switch between relative and count. Count, there's my counts. Relative, there's a relative. They look the same. Visually, they have the same shape, same relative heights. What's changed is where they actually are, because one is proportions, one is counts. All right, so you could, so I'm going to click this button to open up the data set. You could download the data, move it to Excel, sort it if you like that sort of thing. You could move this into Desmos or into your calculator to be able, and kind of move this into 84 and force the classes to be certain sizes. Downside about Desmos, you can't really tell it where you want those bars to start. It kind of does it intuitively and gives you nice numbers. My advice is to use the tool that you saw me use just a second ago, and it's this app called Snip and Sketch. If you're on a PC, it's called Snip and Sketch. Macs might have something similar, but I like to be able to screenshot it. So I'm going to open up Snip and Sketch. I'm just going to actually grab this new one. So I'm going to grab, say, new. It gets rid of the one I had. And I'm just going to screenshot just this portion of my screen. And then what I'm going to do now, and I know I already have the answers there. When you're working it, you don't have those answers. But what I can do is I'm going to use the highlighter to be able to highlight my values. Oh, first we do need to figure out our class widths here. So I'm going to look around and see which one is the smallest number, which one is the biggest. The smallest we call the minimum, the biggest we call the maximum. So the smallest, I see a 52, that's pretty small, so I'm going to give it a highlight. And I don't see anything else that is 52, okay, good. So now I'm going to look through and find the one that I think is the biggest. 72 looked to be pretty big. Was there another one? Usually in class, a student will shout out. They're like, no, 75, oh yeah. Undo. Maybe like, okay, 75 looks to be the biggest. So 52 is the smallest. 75 is the biggest. So with that, let me pop my calculator back up, and you'll see if I do 75 minus 52. And they want us to have 5 classes. So I'm going to take that 23, divide by 5. I get 4.6. We round up to 5. So that's why my classes are 5 units wide, counting the first one. So on 52, that's 1, 52, 3, 4, 5, 6. In practice, you feel like you're adding 5 minus 1 or 4 to go from here to there. But so you can kind of jot that down. So it is 5 wide, but it feels like 5 minus 1. So however that makes sense to you. But in terms of adding, you can just add 5. Add 5 all the way down on both of those. And then I'm going to write across the top here 5 minus 1. In terms of mathy numbers, we're just adding 4, but you have to touch. So 52, 3, 4, 5, 6. All right, so now that I have my classes done, I'm going to go through and I'm going to find the ones that are those right numbers, and again I'm going to turn back to the highlighters. So I'm going to go through and I'm going to highlight those that are 52 to 56. So it's including 52, including 56. So go through and let's highlight 52 to 56. Nope. Yep. So I just see 4, and that's right. And sometimes I would maybe type in 4. I think on this particular question you type it all in before you press enter, or at least maybe go through and do all your highlighting, just so that way if you've missed one, you can find it. You'll be able to catch it. So this one, there should be 11. That's between 57 and 61. 57, 61. 57, 61, 57, 61, 57, 61, all these 61s. So I see 1 on the top row, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that is what we have. And when you just keep this process going, I'll go ahead and finish it. There should be 3, 62 to 66, 62 to 66. There's those 3. These on screen, these pinks can kind of make things be it's a little bit dark for the highlighter, but 67 to 71, I'll just put the highlighter out to the side. 67, 71, that one, that one, that one, that one, so those 4. And then lastly, again, these oranges, these last 3 colors in this app are just dark. And there should be 2 left over. Yep, this 72 and this 75. So to me, that makes life a little bit easier using this tool. I don't have to transfer these things onto my scratch paper, probably mess one of them up, and you can use the tools around the calculator. I mean, right on the computer. And on test, I'm okay in my class if you have access to apps like this doing tests and quizzes. So that's cool with me. It's just a tool to be able to make your life a little bit easier. So now that we have that, now let's find which best matches. So you could move this into Excel, move this into Desmos or in 84 to properly graph this. But guys, look at this. Let's look at this big shape. So I'm looking for one that, first it does say relative frequency, so they all are relative. I'm looking at the y-axis. These are from 0 to 0.6. So that's good to go. It's not all the way up to like 11, which would be like that integer 11. Now just look at the general shape. The second bar should be the tallest, and then the first and the fourth should be tied but way down. So just looking at that fact, do you see how this first bar is not the second tallest, this third one is? This one here, the first bar is the second tallest, but this fourth one should be tied with it, so that's not it, which leaves C. Other things to check also, I didn't say this out loud, I forgot. The x-axis. So if you look at the x-axis, they're all the same as well. So just to double check that when you look at these graphs, check the axes, check the labeling, and then start looking for notable differences. Right. Then, so the class has the greatest relative frequency is the 57 to 61, and the one that's the least is this last one, 72 to 76. All right, one more to do, and that's kind of what I was just talking about of finding the histograms at work. So it says use this data set and technology to create a histogram with 5, 10, and 20. Again, you can convert this, you can click on this, say copy to clipboard. If you're going to do it in Desmos, I would suggest switch it to comma, and then copy it, and it'll stick all the commas in between. Or you can type it into your 84, but you really don't need to. So this one has a histogram that has 5 classes. So they all have the 5 classes. They all have the same X scale, so I'm not needing to worry about that. It's just where would they fall. So here's the deal, guys. I'm going to pick one that is notable. So let's say I see lots of ones. So those that are let me make this one, let me pop this one out. So notice that there are, with these 5 bars, there's 1, 2, 3 in the first bar, 4, 5, 6 in the second bar, 7, 8, 9 in the third, 10, 11, 12, 13, 14, 15. So I'm going to see how many there should be in the first bar. So that's all the 1s, 2s, and 3s. So I'm going to use our snip and sketch tool again. I'm going to highlight all the 1s, 2s, and 3s. And also if I'm looking, this will decide for me, because if you notice this first one says there's just 2 of those, 4 1s, 2s, and 3s, 9 1s, 2s, and 3s, or 8 1s, 2s, and 3s. So if I highlight my 1s, 2s, and 3s, is that all of them? 1, 2, 3, 4, 5, 6, 7, 8. So, and I'm doing a quick double check to make sure I didn't miss one, because this one's 9, this one's 8. So all the 1s, 2s, and 3s. Yep, so that's good. So that's why we get D as our right answer. Now, basically, this type of question is really teaching you, if you view it this way, how to read histograms instead of how to necessarily make them. So I don't need to look at any of the others because I've eliminated all the others because they can't be true, because this first bar has to match. So let's do that with the next one. So histogram with 10 classes, so all of them look like they would have potential of 10. This one at least fills out all of them, so I can see that it's, this first bar would be 1 and 2, 2 and 3 and 4, 5 and 6, so forth. So let's look and see. I'm looking across all of these, and I'm going to look for one that all 3 bars are different. So I'm going to look at this third bar right here. That is the 5 and 6. In this first one, the 5 and 6 only go up to goes up to 5. The second one, the choice C, the 5 and 6 goes up to 3. This one, 5 and 6 goes up to 2. This one, 5 and 6 goes up to 4. So I can save myself time by just counting my 5s and 6s. So let's do that. Because if I count up the 5s and 6s correctly, then I'll know exactly which one it belongs to. So again, 5s and 6s, there's a 6, there's a 6, there's a 5. I just get 3. Was that one of my options? Yep, this one right here. It's close to the 2 and the 4, so I'm just going to do a real fast look for any other 5s and 6s I might have missed. Nope. And as the star indicates, that is the right one. Alright, same thing for this last one. So these are 20 bars wide, which are basically each number. So each number is by itself. So I'm going to see one, try to find one where there is a different number for each. Let's do the ones. So this one has has 1 at 0. This graph has a 1 at 1. This graph has 1 at 6. This graph has 1 at 5. So you can go through and count up the number of ones. 1, 2, 3, 4, 5 ones. I'm not going to mess with highlighting it. And I see that that this is the one that only works. So there's only one graph with 5 ones, so that this has to be the right answer. So hopefully this that kind of shows you how to be able to read these histograms and do those problems a little bit easier. Take the stress out of it. Use that tool to be able just to count. Yes, it's a little bit annoying with some of the counting and the integers, but once you see that, you'll get a little bit hang of it. You might see kind of what they're going for, but ideally, data is not just always going to be integers like that. So real data tends to not be like that. So I wish they did it differently, but you deal with what's handed to you. So as always, if you have any questions, let me know, and then I can maybe make more videos for that. But I'll hope this helped. I'll see you in the next one. Bye.